In section 10, we will multiply polynomials. The use of a calculator is allowed on this section. For each of the following, we will distribute and then rewrite them in standard form. In part A, you will see that you have the same exact binomial inside the parentheses and that we are distributing three different things into that binomial. So for number 1, we're distributing x to the third, and we see what we get here. Number 2, distributing 3x to that binomial, and then 3, distributing -4 to that same binomial. The outcome for those three should be this. When we multiply x to the third and x squared together, we should get x to the fifth. The rule is that we have the same base here, so we add their exponents. Then when we multiply x to the third times -7, we should get -7x to the third. For number 2, when I distribute in 3x times x squared is going to give me 3x to the third. Again, we're taking the degree of 1 here and adding that to 2, and that's where we get 3x to the third. Then 3x times -7 is -21x. Then for number 3, when I'm distributing that -4 in, we should come out with -4x squared plus 28. For part B, this time we have this trinomial, and we are distributing two different things to the trinomial. Answers would be, for number 4, when I distribute x squared in, I end up getting x to the fourth. Again, adding those exponents together, x squared times -4x is going to be -4x to the third, and then x squared times 5 is 5x squared. For number 5, when I distribute the -x in, I'm going to get -x to the third, then I'm going to get +4x squared, and then my last term would be -5x. And then for C, in number 6, I'm distributing 2x to all 4 terms, and in number 7, I'm distributing -3 to all 4 of those same terms. And that's giving me 2x to the fourth, again adding those exponents, minus 4x to the third, plus 8x squared plus 6x. And then for number 7, we're getting -3x to the third plus 6x squared minus 12x minus 9. So now what we're going to do is the same thing we did in part A, but the problem is written a little differently. So here we have x to the third plus 3x minus 4, a trinomial that we're multiplying by this binomial. And there's several ways to do it, and the way that we're going to go through it uses the area model. And in the area model, we have this grid, and we're going to fill in our different terms onto the different parts of the grid. So I'm taking here the first, this trinomial, and I'm going to write that along the side that has more boxes. So I start with x to the third. Now, because I don't have a quadratic term in this case, I have to keep it in the problem, but with a placeholder. So I need to put in a 0x squared so that, again, it still has no value, but it is holding its place. Next, I'll have 3x followed by -4. Then when we look at x squared minus 7, again, we have the quadratic term here. We're missing a linear term, so we write that as 0x, and then finally we have -7. Again, there will be nothing in this box right here. So from here, we're essentially doing the exact same thing we did up above, but now we've got x to the third multiplying by x squared, and we'll put that here. X to the third times 0x, we'll put that here. X to the third times -7, and we'll put that here. And that's going to give us these three values. Now we do the same thing. We're going to distribute the 0x squared to all three of these, which is going to be 0. And you really don't need to put any of the variables in here, but again, they're nice placeholders. Next, we distribute the 3x to all three, and that gives us this. And then finally, we're going to distribute the -4 to all three, which gives us this. Now the final step is that our diagonals of what we just got should be the same. So we have x to the fifth with nothing to combine with. Next, we have x to the fourth. We have 2 of those. We have x to the third. We have 3 of those. We have our quadratic, our squared term. We have 3 of those. Then we have 2 of our linear term and 1 constant. Now, as we combine them, we should get this. So again, x to the fifth had nothing to combine with, so we have that. 0x to the fourth, we could write as 0x to the fourth, but it would be unnecessary, so we kind of just skip that. Then from there, I've got 3x to the third plus 0x to the third minus 7x to the third. That combines to give me -4x to the third. Next, I have -4x squared plus 0x squared plus 0x squared, which is just going to be -4x squared. Next term would be 0x and -21x, which is -21x. And then finally, we have just +28 as the constant. In example B, we're looking at the quantity x squared minus x being multiplied by x squared minus 4x plus 5. Again, we're going to use the area model. As I go to fill these in, I can put them on either of these grid marks, but here I've got x squared minus x. Now you might notice that we're missing a constant term here, and as long as we're not skipping a term that should be in between, such as if I had an x squared and then I had my constant but I was missing my linear term, I don't need to put a placeholder for the constant term here. It's just if we're skipping a term. So then my other side, I'm not skipping anything. I've got to the second degree, to the first degree, and my constant. So I just fill those in here. Once again, I'm going to take the x squared and distribute it into the top, giving me x to the fourth minus 4x to the third plus 5x squared. Then I'll distribute the negative x, giving me negative x to the third plus 4x squared minus 5x. We want to confirm that the diagonals we have are the same term. So again, this first one should not combine with anything. These two can combine, these two can combine, and then this one is by itself. As we combine, we should get x to the fourth. These two combine to give me negative 5x to the third. These two combine to give me 9x squared, and then finally I have minus 5x. For problem C, again, when we're filling things in, we want to make sure, like in this case, I only have two boxes going this way, so I definitely want to fill in 2x minus 3 into these boxes, and then this is my longer one, and I'm going to fill them into the top. Again, I'm being careful to watch for if I'm missing anything. This is the third power, the second, the first, and a constant, so since I didn't skip anything, I don't have to put any zeros in there. As I distribute the 2x into the top, I end up getting 2x to the fourth minus 4x to the third plus 8x squared plus 6x. As I distribute the negative 3 into the bottom boxes, I get negative 3x to the third plus 6x squared minus 12x and minus 9. When I go to combine, 2x to the fourth again has nothing to combine with. I look at negative 3x to the third and negative 4x to the third. Those combine to give me negative 7x to the third. 6x squared and 8x squared will combine to give me 14x squared. Negative 12x and 6x combine to give me negative 6x, and then negative 9 is going to stay just negative 9. Now for the examples here, go ahead and multiply these out. If you would like to use the distribution method, you could just take this 2x squared and distribute it to all four. Then take the negative 5, distribute it to all four, and combine, or you can continue to use the area model. Again, for number 2, I would take the set of parentheses that has the smaller number of terms, so in this case x minus 4, you could distribute the x into all three and then distribute the negative 4 into all three and combine like terms, or you can use the area model. And we'll take a look at these answers. So in number 1, we end up getting 2x to the fifth minus 4x to the fourth plus 7x to the third plus 2x squared minus 30x plus 20. And then on number 2, we end up getting, because several things are going to cancel, negative 4x squared and 4x squared cancel, negative 16x and 16x cancel, so we just get x to the third minus 64. Go ahead and try the next 2 examples. Again, you can distribute or you can use the area model. And as we're looking at our answers here, again, as I'm multiplying things in, making sure the diagonals can combine, and then combining like terms, my answer to number 3 should be x to the fourth minus 5x to the third plus 10x squared minus 11x minus 3. And then for 4, again, I want to confirm that my diagonals are working out properly. If they're not, then I know that something went wrong, and this answer should be 2x to the fourth minus 7x to the third plus 4x squared plus 17x minus 28. And we have 2 more that we're going to find the product of. In number 5, again, double distribute this, or you can set up the area model. Same thing with 6, double distribute or set up the area model. And the answers for these are as follows. And you'll notice that these both ended up being binomials, and we're going to talk about that a little bit more in a minute. But once again, these completely canceled and these completely canceled, so we were left with 27x to the third plus 8. And then same thing with 6. These completely canceled, and we were left with x to the third minus 27. Now we want to look at the 2 answers that we just got and do some comparisons. And so we compare the first factor of the first term, which would be first factor, first term is 3x, to the second factor, first term. So I'm looking at 3x and 9x squared. And over here, I'm looking at x and x squared. And I kind of want to see how would I move from 3x to 9x squared, and how would I move from x to x squared? Well, what I would do then is just square it. So 3x in parentheses squared would give me 9x squared. X squared would be x squared. Now I'm going to compare the first factor, second term, which would be 2, to the second factor, third term, which is 4. And then in number 6, I've got negative 3 compared to 9. And once again, the same relationship holds up. 2 squared is 4. Negative 3 times negative 3, or negative 3 in parentheses squared, would be 9. Now if I compare the product of the two terms of the first factor to the second factor, second term. So if I were to multiply 3x and 2 together, I would get 6x. And then we can see that this one ends up being negative 6x. Here, if I multiply x and negative 3 together, I get negative 3x, and the second factor in the other one is just 3x. Now, one thing I always do with the signs is I remember to use SOAP, and that's going to represent the same, the opposite, and then the last sign is always positive. So what we're going to notice here is that if I were to factor this expression right here, my first sign is going to match, so you'll see that this sign is the same. My second one is the opposite, and my last one is always positive. Again, if I was going to factor this one, I would say that my first sign is the same, my second one is the opposite, and my last one is always positive. So now as we look at these, what we want to look at is, for these signs, it should start with the same. These two should be the same. This one should be opposite. So I know right away that this is going to be a negative. And now the other thing I want to think about is that the middle term comes from the product of these two. So if I do x times 4, I'm going to get 4x, and we already knew it was going to be negative. For number 8, again, the first sign should be the same. So if this is negative over here, that's going to be negative over here. And then from there, I know that this number, the second term in the first factor, squared, should give me 9, which means that this is going to need to be 3. So we end up getting the negative 3 there. For number 9, I'm missing my first term here. All signs are filled in. And again, the relationship is if we take the binomial one, that 2x, and we square it, that's going to give us our term here, which ends up being 4x squared. For number 10, I'm missing the last term, which again, the last term here, squared, should give me this one, and that term is always positive. For number 11, I'm missing the number over here. So we kind of want to look at the patterns that we've seen happening in 7 through 10. How did I get that first number here? Well, the way it works out is that if I multiply x times x squared, I'm going to get x to the third. Here, if I did 5x times 25x squared, I'd get 125x to the third. Here, if I did 2x times 4x squared, I'd get 8x to the third. And then over here, if I did x times x squared, I get x to the third. So with this one, if I do 5x times 25x squared, I should get 125x to the third. And then for number 12, again with the signs, this is the same, both positive. The next one's opposite. So I know my answer is going to be negative. And then from here, this middle term comes from the product of these two. So I have to do 2x times 7, giving me negative 14x in this position. So now what we want to look at is which ones could potentially represent the sum or difference of cubes. And the first thing I'm going to look at is my sign rules. So I know that my first sign is the same as its factored form, so I can't really make a judgment on the first one. The first one can kind of be anything, but then the second one has to be the opposite. So we have to make sure that these two are opposites and that this is always positive. So B is going to get eliminated right away because these two are not opposites of each other. When I look at C, the same thing happens. These two are not opposites of each other. D, they are opposites, and then this is positive. In E, they are opposites, and then this is positive. And then same thing here. These are opposites, and then this is positive. So all the others have the potential. Now I want to look at the patterns here. This one squared should give me this. This one, 3 squared should give me 9, and it does. Then also for this middle term, it comes from 2x times 3. That does give me 6x, so I know that A is going to work. For D, 3x squared is going to give me 9x squared. 2 squared is going to give me 4. And then once again, that middle term is the product of 3x and 2, giving me that 6x. And we've already talked about the signs with these. Here, x squared is going to give me x squared. 4 squared is going to give me 16. Then if I multiply x and 4 together, it is going to give me 4x in the middle. For F, if I do 4x squared, that's going to give me 16x squared. If I do 1 squared, I get 1. And then if I multiply these together, that should give me my middle term of 4x. So then these are the final answers. It ends up being A, D, and F. So now we want to rewrite each of these as the product of two polynomials. So we're going to start with parentheses, a binomial followed by a trinomial. And what we're going to do here is we need to think about the cubed root of each of these parts of the problem. So the cubed root of x to the third is just x. The cubed root of 8 would be 2. So when I go to fill these in, one thing I'm considering would be the signs. I need to make sure that it's negative because it's the same. Then the next one is the opposite, so positive, and then the last one is always positive. From there, if I take the cube root of each of these, I already said it's going to be x and then 2. Now, from here, I know that this one squared should give me this number right here, which is x squared. This 2 squared should give me 4, and so I put the 4 there. Then finally, for this middle one, that comes from multiplying these two together. So I do x times 2, which is going to give me 2x. For 15, again, I want to take the cubed root of each of these. So the cubed root of x to the third is just x. For 64, again, what that means is I need to think about what number, if you raise it to the third power, would then give you 64, and that's going to be 4. Now, when I write in the parentheses here, my sign is going to be the first one's the same, the second one's the opposite, and then the last one is always positive. Cubed root of x to the third is x. Cubed root of 64, we already said, is 4. Now we look at the patterns here. X squared goes here. 4 squared, which is 16, goes here. Multiply these two together, and that goes in the middle position. For 16, again, we look at SOAP. Same sign, opposite sign, always positive. The cubed root of 125x to the third. Well, what to the third is 125? That would be 5. So if I put 5x in this position right here, and then take the cubed root of 8, which is 2, and put the 2 right here. Then 5x squared, I square both of them, so it's 25x squared. 2 squared is 4, so that goes at the end. Then my middle term is the product of these two. So 5x times 2, which gives me 10x in the middle. And then finally for 17, here, signs are the same, then the opposite, and then always positive. So from here, the cubed root of 8 is going to be 2. The cubed root of x to the third is x. Then the cubed root of 27 is 3. Then from there, 2x, if I square both of those, gives me 4x squared. 3 squared is going to give me 9, which goes here. Then my middle term comes from multiplying 2x and 3 together, giving me 6x right here. And now make sure to complete the exit slip that's associated with this lesson, and then your homework is in practice set 10.